So as we take a look at this next one, we can see that our variable is in the base of the exponent. So let's see if I can get this turned on and working. Here we go. Let's try this now. So we'll raise each side to the 2/3. So x equals 27 to the 2/3. And much like the beginning, 27 to the 1/3, the third root, and then we square it. So we're thinking what cube gives us 27? So that's 3. So 3 squared is 9. So the next one, again, it's in our base. So we have to get the base by itself. So we'll divide by 3. So x equals -3/4. X equals, that should be x to the power equals 8. And then once again, we're going to have to raise this each side to the reciprocal, so to the -4/3, -4/3. So x equals 8 to the -4/3, which would be 1/8 to the 4/3. Break that out, 1/8 to the 1/3 to the 4th. So that would be, let's see, 2 cubed is 8, so 2 to the 4th. So 1/16. Let's see, so we're going to move on to the next page. And the next page is some graphing. And we are asked to match this. So let's see, 2 to the x. So if we think of that, it should go through, if we were to make a little table for a, x, y, when x is 0, y is 1. When x is 1, 2 to the first is 2. So that's that table. So 0, 1, 1, 2. So this must be letter A. 2 to the x plus 1. Well, what's happened to that? It's moved up 1. So this has to be letter B. 2 to the negative x. So that's the opposite. So that must be this one. It's flipped. And 2 to the x minus 2, it moves to the right 2. So that has to be letter D. So now we are asked to graph a couple of these. So sketch a graph. So let's start with 3 to the x. And let's make an xy table. So when x is 0, y is 1. When x is 1, 3 to the first is 3. When x is 2, 3 squared is 9. So 0, 1, 1, 1, 2, 3, 2, 9. Okay. Plus 3 moves it to the left 3. So you can take each of those coordinates, 1, 2, 3, 1, 2, 3, 1, 2, 3. So it'll still run along the asymptote, it hasn't changed. Whoops, it's just moved to the left 3. So the next one that we're asked to graph, 1/3 x. So let's do the same thing. Let's make a table. When x is 0, y is 1. 1, 1/3. Well, when it's 2, we'd square both of those because that's 1/3 squared. So 1/9. So 0, 1, 1, 1/3, 1/9. Let's try -1. So 1/3 to the -1. So 1 to the -1, 3 to the -1. So we'd flip it, so 3/1. So we get a -1, 3. So we know it's a decay. The asymptote is at 0. And then the negative on the outside would flip it. So it would be here. Flip it over the y-axis. So we would have it right there. Expand and simplify. So we have to distribute. So x to the half times x to the -1/2 plus x to the half times 2x to the fourth plus x to the half times x squared. And now let's deal with our bases. So this first chunk would be x, half and negative half is 0, plus 2x, we add those, so the 4.5, plus x to the 2.5. Well, we know x to the 0 is 1, so 1 plus 2x to the 4.5 plus x to the 2.5. Well, what does squared mean? We have to write it out twice. So x squared plus 2, x squared plus 2. And we have to distribute again. So x squared times x squared plus x squared times 2 plus 2 times x squared. 2 times 2 is 4. So x squared, so that'd be x to the fourth plus 4x squared plus 4. And then this last one here, we distribute once again. So if we were to write this out, x squared times 2x to the fourth plus x squared times 3x plus x squared, whoops, let's see if we can bring that back here. Here it comes. Sorry about that, guys. And where were we at? So x squared times x to the 1/2. And then if we combine these, so 2x to the 6th plus 3x to the 3rd plus x to the 2.5. So now it's time for a log review. So change to log form. So log base 2 of 10 equals x. Change to exponential form. So our base is 2 to the power of 4 equals x. And now we're asked to evaluate. So without a calculator. So let's set this equal to x. So 5 to the x equals 125. Well, we know that would have to be 3. This next one equals x, so 8 to what power gives us 1. Well, we know that that is 0. The ln, let's rewrite that as a log. So log base e of e equals x. So we have e to the power of x equals e. Well, that would just have to be 1. Let's see, equals x. So this is 16 to the x equals 8. Well, we have to have the same base. So 2 to the 4th to the x equals 2 to the 3rd. And now we can let our exponents be equal. So 4x equals 3. So x would be 3/4. And this next one, let's put this as a power. So this equals x now. So we have 5 to the x equals 625 to the 1/2. And let's see, 5 to the x equals 625. 5 times 5 is 25, 125, so I bet it's to the 4th to the 1/2. So x equals 4 times half, so x equals 2. And now we're going to move on to some condensing. So condensing goes back to division. So you got 48 divided by 3. So log base 2 of 48 divided by 3. And that's 16. So we have log base 2 of 16. This next one we deal with our exponents first. So that's squared. So log base 4 of 3 squared. Log base 4 of 8 minus log base 4 of 36. Well, we could take this 3 squared, and that's 9. So left to right, adding goes to multiplying. So log base 4, 9 times 8 is 72, minus log base 4 of 36. So minus goes back to division. So log base 4 of 2, because 72 divided by 36 is 2. So we're asked to solve these without a calculator. So let's rewrite it. X to the half equals 7. Well, then we could say, okay, raise each side to the 2 over 1. That should be over 1. So x equals 49. So this next one, if we were to rewrite it, 8 squared equals 2x minus 3. Let's see. So we have 64 equals 2x minus 3. Add 3. So 67 equals 2x. So x equals 67 over 2. And this last one, so we got 1/2 to the 4th power equals 4 minus x. Well, we raise both of those to the 4th, so that's 1 over 16 equals 4 minus x minus 4. So that'd be negative 3 and 15/16 equals negative x. So x equals 3 and 15/16. And then number 13, write as a single, or solve this. So we have adding, so that goes back to multiplying. So 2x plus 1, x minus 3 equals the natural log of negative 5x plus 5. Well, it's natural logs on each side, so 2x plus 1 has to times x minus 3 has to equal negative 5x plus 5. So we do some distributing, so 2x squared minus 6x plus x minus 3 equals negative 5x plus 5. It's a quadratic, so set it equal to 0. But let's condense this. So combine like terms, minus 5x minus 3, negative 5x plus 5. Add 5x to each side, minus 5 from each side. So you have 2x squared minus 8 equals 0. We could factor out a 2, so x squared minus 4 equals 0. So, well, that parenthesis has to be 0, so x could be 2 or negative 2. Write as a single log. Okay, so let's make our exponents first and read from left to right. So we have division. So log x cubed divided by y minus log z. Well, we divide there, so we'd have two divisions, but that's the same as multiplying by the reciprocal. So x cubed times y times 1 over z. So log of x cubed divided by yz. So we're asked to find the inverse. So inverse, you switch the x and y. So x equals 2 log 3 of y. And we have to solve for y. So we'll make it an exponent. So x equals log base 3 of y squared. If we rewrite it, this is 3 to the x equals y squared. So then we square root. So plus or minus the square root of 3 to the x equals y. Then we find the inverse of 6. So plus or minus the square root of 3 to the 6th. Well, square root is, we could rewrite that as 3 to the 6th to the half. So plus or minus 3 to the 3rd. So plus or minus 27. Find the inverse here. So x equals 2e to the y plus 1 divided by 2. So x divided by 2 equals e to the y plus 1. Rewrite it as a log. So log base e of x divided by 2 equals y plus 1. Log base e is natural log. Then we have to minus 1 would be our y value.